determine the magnitude, we always overestimate. So how can we can determine the accurate magnitude?
Okay.
Okay.
That's
I can,
Those are the 5 main topics.
yeah.
Well, I can actually show some waveform modeling from our real-time system
Okay.
for this event, if that would help. Okay, do you want me to do that?
Go ahead.
Well, I would say maybe let's save that, Harley, and just try and understand what it is that was challenging for them. Because if they don't have the network geometry or the sampling rate, I'm not sure what the issue is there. You know, you can gear your comments accordingly to which might help them, you know, improve their location.
Yeah, I think you're right. So the question that I didn't understand, there's 2 questions I didn't quite understand. Sampling rate, because for these big events, you don't have to oversample the data. 40 sample per second data is just fine. And then noise.
Oh, is
pretty
this
much
ideal sampling rate, Ben?
At 10 samples per second?
Oh, 10?
What is the sampling rate of your data?
I think almost all is 20, and some of them is 40. But if I read in the book, for the short period is ideal is 100 or at least 80. And for long period, I think maybe we can 50 or at least 40. Yeah. As we know that determining the magnitude is depend on the frequency of the data, right?
Yeah.
Yes.
The saturation, yeah.
So Dave and Harley, this is a theme that I've heard several times, is the question in their mind, what's the ideal sampling rate?
Okay, well, I can tell you, for bigger events, I can tell you what my view is on it. I would start by saying, you know, if you're really looking at larger earthquakes, say 4.5, magnitude 5 or larger. So let's just say 5 or larger. You know, most data loggers will sample at 20 samples per second, or 40, or 80, or 100.
Yeah.
It doesn't, the sample rate, you know, most people want to go to higher, but that's only because you want to look at smaller earthquakes. In your case, I would take lower sample rates if it guarantees that you get the data quickly from the data loggers. So often people do 100 samples per second, and when you have a big event, the compression goes down. You can't compress the data as well, and it takes longer to get the data. For these magnitude 6 events, 20 sample per second data is more than fine, because the Nyquist is 10 hertz, and you're really looking at frequencies for these bigger events of well less than 1 hertz. In almost all of the modeling, the waveform modeling to control magnitudes are done at tens of seconds, not, you know, a tenth of it, you know, 10 seconds or longer periods. So you don't need high sample rates for looking at large events.
But I would like you to tell us what size earthquakes you want to be sure that what's your detection threshold? What's your magnitude threshold where you really start to care?
Yeah.
I assume you don't care about magnitude 1 earthquakes. What is the size that you're looking for?
Yeah, I think if in the national level, the threshold is 5 and in the local monitoring center, the threshold is as small as possible, I think. Below the 5 magnitude is responsibility of the local network, and above the 5 is responsibility of the national service. But the problem is we need the magnitude accurate from the early warning. So we need the as soon as possible and also as accurate possible too. Yeah.
So, but you're concerned as the national network with earthquakes above magnitude 5, is that correct?
Yeah. Right.
Okay.
And for them, that's earthquakes. There are lots of earthquakes above 5.
So I
Yeah.
would agree with Harley that 20 samples per second should be adequate for most of the earthquakes that you're trying to deal with. But it, 40 would be better if you can support the bandwidth.
Yeah. The problem is the first determination of the magnitude is too large different with
Always
the-
overestimate, I think.
yeah, with the final determination. That the problem of our service to the public. Why the magnitude is changed too big? Yeah.
Yeah, so it's bad. You start out with a magnitude 6.6, and then later you're telling
Yes.
6.1.
Yeah.
Yeah.
People feel confused.
Yeah.
Yeah.
It is also might be possible problem to the tsunami warning, right? Because more than 0.5 and the difference of the magnitude. That I think the main problem.
So what is the first type of magnitude that you compute? And what is the final magnitude type?
Yeah, that I think don't really know about that. It is MB or ML or MB small, yeah, but maybe not less than 4 type of the magnitude. But it is also depend of the distance, right? That's why the frequency is important, I think. Yeah. Maybe you can tell us about how to determine the magnitude in USGS. How many stations the first determination? What kind of the magnitude that you have for the first time? Maybe we can learn from you.
Okay. Well, I can, for this specific event, I can show you exactly what our real-time system did.
Yeah. Okay. Thank you.
And so I can show you, I can share my screen and show you, and we can probably go from there. So can I share my screen?
Yeah, please.
Okay, so. Okay, tell me when you can see my screen.
Yeah. Look good.
Okay, so I'm gonna have to do a couple of steps here. Can you still see my screen?
Yeah.
Okay, so the event of interest was, I think, this one on the 10th at 0700. So it was this earthquake right here. It says Java
Yeah.
and remedial. Okay. So,
Yeah.
so this is our real-time system
Mhm.
here, and it's complicated. But the first thing I'm going to show you is a history for this event. And I don't know if you can see my screen very well, but I'll try and blow it up. So this will tell you everything we knew about the event and in what time order and what things happened at what time. So I'm trying to get my screen moved over so I can. Okay, so can you see this this panel that says history right here at the top?
Mhm.
Yep.
Okay, okay. So the first thing to note here is on our real-time system is this time in green right here. So we had an initial location for this event based on the data that you share, that we just get from the public domain and our own networks, the GSN and everybody else's networks. So we had an event location in
3 minutes
3 minutes and
after
3
origin
minutes
time,
from
or after
origin time.
the first detection of the event, or the after origin time.
After origin time.
Okay.
Now, I wouldn't say that's particularly fast, partly because, and I'm skipping through a bunch of stuff that isn't interesting. I have to get to the good stuff. That's not particularly interesting because we don't try and go fast. Okay, so, but you can see here, our first location here, it is in blue. And it gives you a location, and our initial depth, just based on 11 observations, was 6 kilometers deep. So
Which
that was
one the magnitude?
yeah, I'm coming to that. I'll come to it in a minute.
Mhm.
So at 3 minutes 35 seconds, we had a location, and then we still didn't have a magnitude. Oh, here we go. Then right here, you can see at 3 minutes,
So,
40 seconds.
3 minutes after location determination.
No, everything's relative to origin time.
Oh,
If I say 3 minutes, 40 seconds, it's after origin time. Okay, everything will be based on origin time.
oh yeah, might be 5
Okay,
5 seconds after the hypocenter, right?
say that again.
5 seconds after hypocenter determination. 5 seconds.
No, it's 3 minutes, 40 seconds after origin time.
Yeah.
Okay, everything's relative to origin time.
Okay.
Harley, he's saying you had a magnitude 5 seconds after you had your initial blast location.
Oh, yeah, oh, that could be,
Yeah,
yes. Okay,
yeah.
I missed that. Okay. And we had an initial ML of 6.5
Mhm.
and an MBLG, which only we compute of 6.1. So if you come down, there's lots of stuff you can see here. A few seconds later, we have you can see when we went to 12 observations, our depth jumped to 58 kilometers. Okay, I should explain. We have 2 locators. We have an associator that locates, and then it hands it off to a real locator. The associator said it was shallow, but the locator immediately put it deeper. And it says here, it put it at 59 kilometers deep. Okay. We never used the associator location. Okay. And then you could it just keeps updating every time there's more data. What I'm doing is I'm looking for when did we have, so we have a new magnitude here at 3 minutes, 59 seconds. It was an MWP. It's a magnitude where you can integrate the displacement of a seismogram. If you go to displacement and you integrate it once more, moment this is Suboi method. The moment scales to the integrated displacement. So at 3 minutes, 59 seconds.
Excuse me. You determine the MW using the waveform inversion.
Yeah, that isn't, we didn't, at 3 minutes, 59 seconds, we didn't have enough data. So I'm kind of going through which magnitudes we had.
So what's interesting there, Harley, is that you have a 6.59 ml at that point. So magnitude
Yeah.
discrepancies are not unusual, you know?
No, that doesn't bother me at all.
Right.
Yeah, and especially because ML is really a crustal and this is a deep event, it's likely to be biased high because it has the appearance, it's got deeper, it's not being, and it's in a subduction zone, it's probably looking snappy. You know, it looks like a snappy earthquake. So I'm just gonna probably within a few minutes.
Excuse me. May I know how many stations from the first determination until the last, maybe from the first determination?
Well, here at 4 minutes and 8 seconds, I don't know, it probably says somewhere how many observations there are. I don't see it in here.
Because I think it is very important to us. Yeah.
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 It's not very many. It's in the order of 12 to 14, I would guess. Well, you can see here at 4 minutes, 50 seconds here, you can see that we've only have 13 observations.
Okay, yeah.
Okay.